Have you ever asked yourself, dear geologist, what are the large-scale problems associated with plate tectonics? Is there any indication at the Earth's surface of the formation of convection cells? And are there any findings or evidence from new research papers of mantle convection? How do those massive slabs of solid rock float dissipate their tremendous weight? How frictional sliding can occur at the depth of 700 kilometers with higher temperatures? If the Earth is not getting any larger, then what is happening to all that seafloor that is plunging downward? According to playtectonics, no rocks older than 200 million years in the world's oceans. Well, why thousands of rocks, Paleozoic and Precambrian age, have been found there? Are there adequate mechanical basis for plate tectonics theory?
After more than half a century of accepting plate tectonic theory, I think it's time to questioning and discussing this theory in order to understand more precisely the nature of the Earth, because this theory has become more complicated and distorted since its birth. Each new fact forces us to invent a new complication, a new hypothesis that once again saves the basic theory from destruction. It's time to abandon dogmas and step back to the basics, rethink all geotechnic theories for their conformity to facts. For somebody, plate tectonics are no science but a religion. Therefore, officials from science do not allow heretics with their inconvenient facts in highly rated journals and oral reports. Is it frightening that air castles suddenly dissipate under the pressure of facts?
Well, plate tectonics, the reigning paradigm in the earth science, faces some very severe and apparently fatal problems. Far from being a simple, elegant, and all-embracing global theory, it is confronted with a multitude of observations, anomalies, and has had to be patched up with complex variety of ad hoc modifications and auxiliary hypotheses. In this series of geological studies, I will try to describe more than a century of geodynamic ideas and review what is wrong with plate tectonic theory by taking the views of a group of geotechnical professors around the world. Some of them strongly support this theory, and others of them try to illustrate the weakness of this theory. Please be with us in this series of review studies in order to show the truth to the geological community, in order to urge them to do more research and studies for the purposes of changing this outdated theory, and also how can students be taught to question prevailing currently popular theories if they are only presented a one-sided view. Questioning and challenging prevailing popular theories is what science is all about. Remember, popularity only measures popularity, not scientific correctness. Science is a logical process, not a democratic process. I am Shaheen Al-Hermezi, Chief Geologist and Remote Sensing Expert.
I am Vladimir Anokin, Doctor of Science, leading scientist of the St. Petersburg Academy Research Center, and a professor of the university in Russia. I studied geotectonics many years, including fields and marine works. My opinion about plate tectonics is as follows. There are a set of fundamental limitations that have been imposed on plate tectonics by its authors. The physical basis of plate tectonics is not proven. Over time, a large number of facts have accumulated, contrary to plate tectonics. But the inertia of thinking for decades does not allow scientists to abandon the outdated paradigm, forcing them to invent more and more new sub-theories and sub-models for guard the plate tectonics. As a result, plate tectonics lost their original simplicity and logic. This situation cannot continue a long time. The history of science is a history of changing paradigms. And if we are looking for the truth and not just grants, if we recognize the priority of the fact over the theory and model, we will have to reconsider our views on geotectonics in accordance with reality. I believe that the time of the revolution in the geotectonics is approaching, after which a new paradigm will burn that generalizes all existing volume of facts at a new level. Plate tectonics for a long time contributed to the development of science. Now it hinders science, and it's time to change it. It's time for serious reflection on an alternative geotectonics paradigm.
Part 1 of this review study about mantle convection. According to plate tectonics theory, the Earth's mantle is convecting, turning over and over in an endless loop. Convection is assumed to take place in the mantle as solid state flow instead of liquid state flow. Well, is there any indication at the Earth's surface of formation of convection cells? And are there any findings or evidences from new research papers of mantle convection? The idea of convection comes from what is observed when liquids are heated from beneath. The heated liquid expands a little, becoming slightly less dense than the colder liquid, and thus tends to rise to float to the surface. Cold liquid rushes in to fill space that had been occupied by the heated liquid. In a large volume, a geometric pattern of typically hexagonal shaped convection cells often develops. Convection is assumed to take place in the mantle as solid state flow instead of liquid state flow, but there is no indication at the air surfaces of formation of convection cells. Indeed, decades of research has yet to find any direct and ambiguous evidence of mantle convection. Is the idea of mantle convection simply a contravent to make plate tectonics seem to work? Is there another way of looking at the dynamics of the Earth? There are serious questions to consider. Well, let's go and hear from research-gate geologists around the world. Alfred Wegener currently works at Robert Schumann Institute, Belgium. In his reply for our mantle convection questions, indicated that mantle flow due to convection is due to the temperature differences between the Earth's core and mantle. We do not yet understand many details, but I think isn't it, mantle convection is a main driving force for plate tectonics. Also, George Costa de Mora, Doctor of Geochemistry, Senior Technologist Geologist at the Department of Radioactive Wastes at the Brazilian Nuclear Energy Commission, says in his reply, "I believe in plate tectonics. For me, it explains everything in the earth geology. What I don't believe is the cylinders theory, convection currents. This is the most stupid thing I heard in my whole life." Another reply from Dr. Dirk Muller is a well-known consultant and geologist with over 34 years of experience in the oil and gas industry from Amsterdam, says the old concept of hot air interior generating convection current still makes sense. The basic physics of heat generation has a lot going for it, and the associated mechanics of the convection and plate movement also make sense. Heat generations flows from gravitational compaction in the earth interior and from radiogenic heat generation in the earth's interior. Together, these processes generate the heat that is required to drive convection and plate tectonic. Professor Malay Mukul from Indian Institute of Technology, Bombay, working in full trust-built structural geologist, says we obviously don't have direct access to the mantle, except some mantle-derived magmas and xenolites, and a lot of what we know is based on seismic tomography and numerical models. It is likely to remain so. It is a fascinating area of research, and I am sure you'll find where things stand if you get into the relevant literature. But Paul G. Tagley, in his review titled Mantle Convections and Plate Tectonics Toward an Integrated Physical and Chemical Theory, stated, according to recent seismic evidence for convection and mixing throughout the mantle seems at odds with chemical composition of erupted magmas, requiring the presence of several chemically distinct reservoirs within the mantle. He says seismic waves provide a direct probe of structures inside air. Chemical analysis of erupted lava and other volcanic products give information about different compositions that exist in the mantle, and laboratory experiments determine the properties and deformations mechanics of rocks at the high pressure. Despite 3 decades of research, some first-order questions regarding the plate mantle system remain largely unresolved. And he also explained that the problem is complex because mantle rocks exhibit many different deformation mechanisms, ranging from brittle failure to viscous creep, depending on the pressure, temperature, differential stress, and past history of deformation, and many of these mechanisms are not well quantified. The second major question is how the differing chemical composition of erupted magmas, which require several chemically distinct reservoirs within the mantle, can be reconciled with other observational and dynamical constraints hovering rule mantle convection, which should mix chemical heterogeneities. The new plate mantle geochemical models are untested by a full range of dynamical and observational constraints, whereas the plate tectonic models are not realistic and include only a simplification of rock rheology.